Welcome to My Practicon. Today, let's discuss about material properties. Material properties plays a major role to estimate the structural member capacities. Some of the key material properties are yield strength, ultimate strength, and unit weight of the material, modulus of elasticity, shear modulus, Poisson's ratio, coefficient of linear thermal expansion. These are the critical and major properties normally used in engineering calculations for the steel members, steel structural members. The range for the yield strength, it starts from 200 to 450 and more. It depends upon the type of the steel members manufactured in the industry. So similarly for ultimate strength, the approximate range 340 to 550 Newton per mm square or MPa. Unit weight of steel. This first actually the yield strength and ultimate strength normally used to calculate the compression and tension capacity of the members. For unit weight of the steel, we used to calculate the steel weight of the member such that the self weight of the member will be utilized during the analysis of the structures. And modulus of elasticity. The modulus of elasticity is a property of material that measures a resistance to elastic deformations, generally measured as slope of the linear part of the stress strain curve. Similarly, the shear modulus is around 81,000 MPa. The shear modulus is coefficient of elasticity for a shearing force or the ratio of the shear stress to the shear strain or the displacement per unit length. So this is called shear modulus. Now, Poisson's ratio. So what is the Poisson's ratio? It actually shows the material deformation. How it calculates actually the transverse strain to the longitudinal strain is called as a Poisson's ratio. The lower the value, the more resistance of the material for the deformation. So right now the acceptable range is 0.30 and depends upon the steel, the combination, how it has been manufactured. It may ranges from 0 to zero point 0.5, but the ratio is more means the steel is not good to resist the external forces. The lower is more strength and the higher is less strength. Coefficient of linear thermal expansions. The coefficient of linear thermal expansion, the physical change of the material in response to known temperature changes. So this is actually, due to the temperature, the contraction or expansion of the material, generally widely used in the estimation of the railway tracks, design of the railway tracks and all those things. I mean, that is a typical example. So these are the typical material properties which is engineers should be in handy while doing the calculations. Most of the data will be provided by the manufacturers. However, these are the very important material properties which will be required for design of steel structures. Thank you. Please subscribe to the My Practicon and we'll follow the more videos for uh, detail of civil and structural engineering. Thank you very much.